Hey y'all, this is the first set of notes on fish. We're going to go over some introductory information and cover some anatomy of fish. So first up is classification of fish. Like everything else in this course, we're in the kingdom Animalia. Now we're in the phylum Chordata, which means they're going to have a spinal cord or notochord. And then a subphylum for the rest of the semester is vertebrata, so everything's a vertebrate. There's two classes we're going to look at with fish, is bony fish and cartilaginous fish. So bony fish is fish with bones, and cartilaginous fish are fish with cartilage and no bones. So like sharks and stingrays are in that category. So now we're going to go over some anatomy, starting with the fins. So first up is the caudal fin, which is the tail fin. It's used to propel the fish forward. Then there's dorsal and anal fins that help stabilize the fish and prevent it from rolling over. And then there's the pectoral and pelvic fins that come in pairs, and they help hold the fish steady and help it aid in swimming around and maneuvering, and also can help it kind of brake and slow down as it swims. So to show you on the diagram here, pectoral fins are these side fins. The pelvic fins are these bottom fins. The dorsal fin, sometimes there might be one long, might be kind of broken up into two like this guy. It could be spiny or soft looking. So those are on the top, the caudal fin is the tail fin, and then the anal fin is down here. All right, so now just talking about the caudal fin or the tail fin. First up, they're kind of divided into two categories at first, which is a heterocircle tail, which is a type of caudal fin usually found in sharks where the upper half is larger than the lower half. So you can see on this shark here, this upper half is much larger than the lower half, versus the homocircle tail, which is usually found in bony fishes and not in sharks, where the upper and lower halves are lobes are the same. So here it's pretty even on both halves. Right. Then there's some other categories or types of caudal fins. We'll go over a few of them. The first is the continuous caudal fin. This is generally found in eels like this guy here, and it's just like blends in right like an extension of the body. So it's not really like, we're not really sure where the tail starts and the body ends kind of thing. And these fish are generally helps them swim into cracks and crevices versus having like a big tail that would stick out from the body, right? The next is a lunate caudal fin, which they tend to be found on very fast swimming fishes and help them maintain rapid speed for long durations. And that's what it looks like on fish. Then there's a forked caudal fin, and these are generally found on continuously swimming fish. And so you can tell there's a very distinct separation between the two lobes. Then there is the truncate caudal fins, which are usually found on strong but slow swimming fish, and they end very abruptly. Normally there's a slight curve inward to the fin. And then the last one is the rounded caudal fin, which is usually found on strong but slow swimmers, just like the previous one. But this one just curves outwards a little bit versus inwards. Make sure for your test, you want to know these different fins and be able to match them to the diagrams here. I'm not going to give you all of them, but you potentially could see any of them. So make sure you know like what they're called based on what they look like and what kind of like fish they're found on, like strong and slow swimmers. All right. Moving on to fish body shapes. The first body shape is the fusiform shape. It's a very football-like shape fish. They're generally found on very fast-swimming fish like sharks and tuna. And you can see that it's narrow at both ends and then fatter towards the middle like a football. The next one is the eel-shaped fish. They're elongated fish, obviously eels, and as well as needlefish are this shape, like this guy here is a needlefish. Then we have one of my more favorite ones, just because they're funny looking, is spherical shape. They're ball shaped and they inflate in order to avoid being eaten. And I'll post a video for you guys to watch of some puffer fish. They're not actually always going to be round. They're normally going to look like this down here when they're not inflated. But puffer fish and porcupine fish are two fish that fall into this category of body shape. And then there's the most common, or I would assume would be the most common one, is the laterally compressed fish. And their body shape is perfectly adapted for hiding in the cracks and crevices of rocks and reefs, and just helps aid them in being able to swim efficiently. Butterfly and angelfish are in this category. A lot of other fish are in this category. To me, this is like the fish body shape that you're going to think about when you think of a fish. Right. And then the last one is the depressed fish, which is an unfortunate name for the body shape, but accurate in the way it looks. These guys are horizontally flat. They're a stingray falls in this category, so it looks like they've just been like squashed or stepped on, and they're flat that way instead of being like the normal fish shape. A lot of times these fish are going to be camouflaged or have the ability to change color so that they can match the bottom of the ocean and hide. Some of them might bury themselves in sand a little bit just to hide out from either prey or predators. All right. Now we're going to move on to fish scales. The general purpose of scales is to provide protection for the fish. Most fish are going to have one of these 4 types of scales we're going to go over. There are some others, I believe, but we're going to stick with these 4. The first one is the cycloid scales. These are going to have a very smooth surface to them. Carp and salmon are going to have these, and you can see here in these pictures of them that they just kind of have this like little bit of overlapping to them, but overall have a smooth like texture to them. Then there's ctenoid scales, which have teeth-like edges to them and are rough to the touch. So bass, bluegill, and perch are going to have these, and you can see here in this close-up that they do indeed have this rougher texture to them versus the previous slide had the very smooth texture to them. Then we've got placoid scales, which look like tiny teeth or thorns, and these are going to be very sandpaper-like. And sharks and stingrays are going to have this. So when we dissect sharks, you're going to, when you touch the skin of them, you'll feel that rough sandpaper-like texture to them. The ones we have aren't the roughest texture to them, but they definitely don't feel smooth. Right. And then the last one is ganoid scales, and these are hard interlocking diamond-shaped scales. And you can see here this it's just like little rows, almost looks like little bricks lined up horizontal or diagonally. And generally, I believe these are pretty smooth to the touch. All right, you might feel the edge, the lines a little bit, but overall they're pretty smooth to the touch. All right, some other things involving anatomy is that there are barbels, which are whisker-like tactile organs found around the mouth of a fish. Not all fish are going to have these, but catfish and goatfish and some sharks will have these as well. And they have taste buds in them that allow them to search for food in murky water, because if they can't see very well, they can use this to help search for stuff. So if you see anything like this on a fish, it's a barbel. Fish are going to generally be covered by a protective transparent skin, which produces a lubricating mucus, and it's going to help the fish move through the water. It also might help protect them from things such as the sting of a sea anemone for the clownfish. That's why they can live there, because that mucus kind of coats them and prevents them from getting stung. But other fish, their mucus might not help with that. So it just depends on the fish of how good their mucus is. All right. Next up is the swim bladder. The swim bladder is a thin-walled sac that can inflate or deflate when the gases from the blood pass into or out of it. And this will help them be able to move up or down in the water column, depending on if it's inflating or deflating. If it's inflating, they're going to go up. Deflating, they're going to go down, because the gas is going to be less dense than the water, so it'll help it rise and lower in the water column. But for sharks, they're not going to have a swim bladder. They're actually going to utilize the oil in their liver to go up and down in the water column. So they have extremely large livers for their body size, and they're filled with an oil. And you'll see this when we dissect, that you'll open them up, see these giant livers in them, or giant liver in it, and it'll be very oily to the touch, and oil will get all over your tray, and it's just a mess. But this oil is less dense in the water, and it helps with their buoyancy. They're also generally going to be constantly swimming around, and the lift from the flow of the water over their lateral fins will help them help prevent them from sinking as well. So that constant swimming helps them from just sinking to the bottom of the ocean. Right. And then the last thing for this set of notes is their senses, and they're going to have all 5 senses like we do, but they're also going to have an additional 6th sense, which is the lateral line system. And that lateral line is just goes along each side of the body, and you can see here on this fish, it's just this thin little line right here, and that has like sensors on it, or cells that can help detect movement of other organisms around them and changes in the water, like pressure and current. So it just adds another layer of sense, another sense to help aid protection of getting eaten or things around it. Just knowing what's going on around it that they may not be able to see, but they can feel with through this lateral line system. Right. Well, that's it for this set of notes.